How are you everyone? Today we're gonna look at MS dataset. This dataset is looking at number of basic tasks completed by users via this iOS platform app. And as we can see from the title, you can understand daily MS change through this smartphone data. And what we're gonna do here is trying to use this test scores and users' information to create a binary classification to differentiate MS patient with control. Now let's look at how we actually do it. First, we're gonna load up the dataset for sure, and we're gonna inspect how is the quality of the data. We can see the columns and rows are pretty clear. However, when looking into details, we can see there are several columns with many null values. Actually, they pretty much doesn't have any actual values. So, in conclusion, 3 columns are not be able to be used for building a model due to lack of data. And there are some empty values as many tests are not completed by the users. To clean the data, we're going to drop the columns with too many null values. We're also going to change the data type of these columns, and test metric name, code are the same as test name, test code. So we're gonna drop some columns too. Alright, you can see we dropped these columns, and further manipulating, I've dropped these columns. What we're gonna do is create a pivot table which looks like this. So we have test full name, which is concatenated by test name and test code, and this is their score. So our data set makes more sense now. Now we step into pre-processing. As we mentioned, look into this pivot table. Look into the pivot table. Sorry, folks. We can see many tests not completed by users. So we're gonna fill these null values by the mean of each test. And in terms of feature engineering, we're gonna scale the data, because you may see my ADD document. I first try to normalize the data, but it actually undermines the model performance. And label encoder for users, country of resident, birth year, weight, height. And after we've done that, we're gonna start building a model. First, we're gonna partition the data, and 2 machine learning algorithms we're gonna use are logistic regression and random forest. To use logistic regression, because this is very classic algorithm for binary classification, and what we're facing is binary classification problem, and the dataset is not enormously large. So we can try with logistic regression first. We split the data, cross validation, and use sklearn. From sklearn library, we fetch the logistic regression model, and we use accuracy as the evaluation of the model. It scored 78. It's not too bad. Let's look at random confusion matrix. And the false positive rate is 0.16. Now try with random forest. Again, we import the algorithm from sklearn library. As we can see, the model this model has 78% at 0.78 of accuracy, which is basically the same as our logistic regression. And we can see the false positive rate is slightly higher than logistic regression. Now we're going to build another algorithm with deep learning method. This is not a big data set, so we're only going to have 3 layers. First layer, we're going to use ReLU as activation. Second layer, same, ReLU. And the output layer, we're going to use sigmoid because it is a binary classification. And we use Keras library for readability and simplicity of the code. What we're getting is the presentation is direct here, so we're going to look at Jupyter Notebook. The accuracy is 70%. It doesn't outperform simpler machine learning model, and I think it's because our data set is not big and it doesn't require deep learning or neural network. And this is the end of my presentation. Thank you very much.